This demonstration showcases self-service data preparation and machine learning modeling using the combination of Trifacta and DataRobot to predict customer default loan payments. To achieve the most accurate prediction, Trifacta will combine and clean large sets of variables calculated from disparate data sources, so DataRobot can test various models and identify the best one with the most robust prediction. Let's start with Trifacta to clean and combine the data for DataRobot. The member dataset provides individual information about the borrowers, such as their incomes and length of employment. We must convert the length of employment into a numerical value, and we need to remove the noise from the data. With Trifacta's interactive suggestions, I can brush over some values, and Trifacta suggests and learns from my interactions to present in real time what the data looks like. Adding to the data preparation recipe on the right, I can compose a repeatable way to clean and structure the data. Trifacta infers the data types and provides data quality signals for valid, missing, or mismatched values. Zooming into the mismatched values, I select Trifacta's suggestions to convert the NA values into nulls. With just a few clicks, I was able to extract the discrete values from my model. With the same principle, I'll do the same cleanup for the yearly income variable, such as converting K values into zeros. Trifacta can also calculate metrics and combine both aggregated values with individual row details for more features to the model. The user interaction is recorded in a recipe of steps to prepare the data and make it repeatable for the best accuracy to feed the DataRobot predictive model. Proceeding with the same principles, Trifacta can combine, clean, and enrich disparate data sets to deliver the variables to DataRobot for testing various predictive models. Running the recipe, data is loaded in DataRobot. Trifacta visually represents the data flow, showing the combination of member info, status lookup table, and member loans. This lineage is very useful for maintenance and auditing. DataRobot can now be used to test models and identify the best predictors to a loan default. We select loan status as the variable we want to predict. Next, we kick off DataRobot's Autopilot Mode. In this flow, DataRobot will search automatically for the best modeling approach for our dataset. To do so, it starts by testing 30 to 40 different modeling approaches with a small sample of our data and uses a survival of the fittest approach to hone in on the approaches that are performing best. While the right-hand side shows jobs in progress, completed jobs will start to appear on the model leaderboard, rank ordered based on the accuracy metric score. Modeling algorithms are sourced from many of the best libraries available, including Python's scikit-learn, R, Google's TensorFlow, XGBoost, H2O, and Spark. Each of the models is defined by a model blueprint that can be customized. The blueprint steps may range from one-hot encoding for categorical variables to more complex transformations such as ratios between features, TF-IDF and other text preprocessing, and applying unsupervised learning techniques such as PCA and K-means. Now that we have our best performing models, we can drill down into individual models to better understand which features are most contributing to model performance. To assess model quality, we may use the lift charts to see that the model is effectively separating loans with higher and lower risk, or the confusion matrix to allow us to identify trade-offs depending on our risk tolerance. For example, we can see how many good and bad loans we will have invested in and passed on if we want to invest in only loans that are at least 90% likely to be paid back in full, versus if we lower our tolerance to 75%. Feature impact helps us identify the features that most contribute to the accuracy of a model. We can see top variables, including the loan title provided by the borrower, the interest rate, the borrower's debt-to-income ratio, and the loan grade given by the lender. We can understand at a row-by-row level that the top loans are low risk because they have relatively low interest rates and have been given a grade A, whereas these loans are high risk because the individuals applying for them have low annual incomes and high debt-to-income ratios. When we're comfortable that this model is ready to go to production, we can use one click to deploy the model to a DataRobot prediction API. We can use the Trifacta recipe in conjunction with the DataRobot model to automatically transform and score new data. Thanks to Trifacta and DataRobot, you can now enable self-service's advanced analytics to every data professional and at a speed and scale never attained before.